So thanks everyone for sticking around and coming to this session. I know Cam Davidson Pilon is speaking on mistakes he's made and a lot of the probabilistic type programming work he does. Personally, that's kind of where I'd be right now, so I'm flattered that all of you are here. So hopefully some of you still have room left in your brains after the rest of this weekend. I know it's the last talk of the weekend, and I'm pretty filled up conceptually at this point, so hopefully there's a little bit of room left. But if you don't have any, I'll forgive you. I'm going to be talking about the term data-driven, and based on this title's talk, you can probably guess I'm not the biggest fan of it, but we'll get a little bit more into that shortly. So I'm Greg Reda. I'm a freelance data scientist based in Chicago, but I've previously worked for a big consulting accounting firm called PwC, a small data science consulting firm called Datascope, which has greatly influenced this talk. And I've also spent 3 years at Grubhub, where I did a lot of data work there. If you recognize that cartoonish avatar, you probably have used Grubhub, or you've Googled something pandas related and wound up on my blog, where I've written some pandas tutorials. You can find me online at all the usual places. I'm typically GJ Reda, and I'll be posting these slides there to my GitHub once I actually finished. Well, I finished tweaking them shortly before this talk, so they're not up there yet. So how many of you would say you're data-driven in a literal sense, like you actually use data to drive all your decisions, or at least would prefer if you could use data to drive all of your decisions? Okay, so a couple of you. I don't think I am, or at least I kind of hope I'm not. I love data, don't get me wrong, but I don't like that term. I think being driven by data alone is somewhat of a flawed approach. And hopefully by the end of this talk, you'll understand why I feel that way and maybe even be nodding along a little bit. The nice thing about setting the expectation that you might be nodding along is that I won't be able to tell whether you're nodding along or nodding off to sleep. So either way, I'm going to take it as a compliment now that I've actually said that. So about the term, it feels like it's being used more and more, and that every company, every organization, whoever it may be, is kind of trying to one-up each other at this point in terms of how data-driven they can be. But do we really think this is a good idea, to be driven entirely by data? I've been known to go on my fair share of rants. Justin and Drew over there can certainly attest to it. They're my former coworkers. And this is one of the topics that's been known to kind of kick one up with me. It feels like everyone's just trying to be data-driven, data-driven, data-driven. So I think part of the culprit might be the rise of this book and this term, Moneyball. Have any of you seen the movie or read the book? Okay, a lot of you. For those of you that haven't seen it or read the book, please forgive the sports ball references I'm about to make. I know I'm at a tech conference, but I'm a baseball fan, and I think that this was an extremely interesting book. So even if you're not a sports fan, I would at least recommend seeing the movie. It's kind of a cool story. But to give you a brief overview of it, it tells the story of the Oakland Athletics, who are a Major League Baseball team with perpetually one of the lowest payrolls in baseball. And the thing with baseball is that there's no salary cap, which means that I can spend however much money I want to sign all of the players I want. This greatly favors large market teams like the Los Angeles Dodgers or the New York Yankees, because they have larger fan bases, they live in higher economic areas, they bring in a lot more revenue than these smaller market teams like the Oakland Athletics or maybe the Kansas City Royals. To illustrate the point, this year the Dodgers are spending more than 3 times the amount of money that the Oakland Athletics are. So but despite all of this, the A's kind of have an interesting story and were pretty successful for a while. My argument is that this is kind of partially to blame. It's probably the most, I would say over the past decade or so, it's the most well-known kind of reference in terms of using quantitative information to improve things in popular culture. So it's so much so that sometimes you hear about startups that, we're Uber for X, we're Uber for Y. Well, there's Moneyball for sales, Moneyball for government, Moneyball for bankers, Moneyball for golf. There's even Moneyball for life. And so I think that it's kind of gone a little bit too far. But everyone who kind of is familiar with this term and familiar with the book or the movie takes away that it was this battle of the scouts versus the stat heads. And I'll get into what kind of scouting is in a little bit for those of you that aren't familiar. But everyone takes away that despite their tight budget, the A's were perennial contenders for much of the early 2000s. They made the playoffs 5 times in a 7-year period. That's kind of unheard of given how little money they were spending. And they did this by making heavy use of statistics and analytics to exploit market inefficiencies. So for example, if people are familiar with baseball, you get a base hit, you go to first base, eventually you try to make your way around the bases and you score a run. That's how you win games. You score more runs than the opponent. But you can also walk. And if you take a walk, it's the exact same outcome as a hit. You wind up on first base. Well, the metric that everyone's always cared about historically is the batting average. How good is a person? How often does a person get a hit? But the A's found that on-base percentage, which is hits plus walks, plus whether you get hit by a pitch, is more highly correlated with winning success than batting average. It seems like a very duh moment right now, that it's the exact same outcome. You wind up on first base. But in the early 90s and 2000s, no one cared about on-base percentage. The A's were the only team that actually realized how valuable this was. So they were signing players that typically were far, far more expensive because they had great batting averages. But if they were getting on base at a higher rate than other people, what does it matter? So the A's were able to produce wins very cheaply. What everyone takes away from the story is that the stat nerds were able to kind of exploit these market inefficiencies to kind of to further outcomes, to better the outcomes for the A's. But what people forget is that scouting, traditional evaluation of players via the naked eye, played an important role too. In baseball, there's something called an aging curve, which is something that got kind of developed through a lot of research in the early 2000s. Baseball players, you can see by the curve, this is the aging curve for an offensive player, for a hitter. And it kind of peaks around their late 20s to early 30s, and then drops off greatly. And this is runs above average. So essentially, how good of a player, how much better than the average a player is at a certain age. So that it drops off greatly, and what had historically been happening was that a player typically reaches free agency after they've been in the major leagues for 6 years. Over that time, you're typically paying them under their rookie contract. Rookie contracts are very cheap. You drafted someone out of high school, you drafted them out of college, you're not paying them a ton of money yet because you don't know they're an established player. So you have them under contract for a period of time, and then eventually they probably hit free agency around the age of the late 20s, early 30s. So a lot of these other teams would then immediately go sign away that player. They'd go to the Yankees and then go take a huge contract. So these young players are extremely valuable, so it makes sense to try to find them early on in their career, take that risk, and then you have them under contract where they're producing a great number. They're producing very well for a cheap contract. So an example of this is, to illustrate this point, I'm going to talk a little bit about Mike Trout. So he's an outfielder for the Anaheim Angels. He's 23 years old, and he's in just his 4th season in the major leagues. And he's in his 4th season now. He's already played 3 full seasons. Within those 3 seasons, he's already won the MVP award, and he's finished runner-up twice. He's universally regarded as the best player in baseball. However, last year he only made $1 million. And the year before that, he made the major league minimum, which is about $500,000. Now, if you compare that to a great pitcher in baseball, Clayton Kershaw, who's a well-known established player, Clayton Kershaw makes $33 million this year, which is 40% of the Oakland A's total budget this year. So you begin to understand the importance of drafting great players and acquiring them while they're still on their rookie contract. Scouting is crucial to this process because we quantify the current performance at the major league level. Sure, we could potentially try to do some forecasting, but there hasn't been a ton of great work yet. we're kind of reliant upon the makeup of a player and understanding how they might perform at the next level by seeing things like their bat speed, how quickly they run, that sort of talent. So while everyone thinks that it was about the scouts versus the stat heads, the reality was that it was through quantitative analysis and qualitative analysis by their scouting department that the A's were able to beat the odds stacked against them. And following their success, most teams across all sports have begun to adopt the use of advanced statistics and quantitative analysis, whatever you want to call it, in some form. So building on top of each other's work, they were able to kind of produce better results. They weren't data-driven alone. Another dichotomy that I've kind of seen happen in the past is the quants versus the creatives. So maybe the data scientists versus the designers. An experience that I've had with that was I was talking a couple years ago about with a company that was doing creative type work, Pixar type entertainment for children, but on tablet devices. So you're carrying your iPad around and your kid could essentially watch Pixar-like content, but there was a little button on the screen, and if your child pressed the button and talked to the content would respond and kind of change. So it would morph a little bit with what your child was saying to it. When I was talking to the company about doing some work with them, they assumed that there was automatically going to be a conflict. So it was a small company, 10 people, and they had the assumption of, I'm a data person. All I care about is data, the quantitative aspects of it. They are established in the entertainment field, and they know intuitively, they have a good idea of what's going to work. They assumed that there was going to be a large fight between my approach to working and their kind of gut instinct about what actually works. But in reality, we all kind of need to empathize with our users and understand with them, and data aids in that understanding. The work I would have been doing would have given them a better understanding of what is and isn't compelling content. And I think we as data scientists have a lot in common with designers and other creative folk. A pretty well-known design consultant who does a lot of writing on the topic, Mike Montero, recently wrote an article called Why You Need Design. Or he recently wrote a book, and within the book there's a chapter called Why You Need Design. And the design process, he says, design is the process we undertake to solve a problem. Now, I've never had a designer job title, nor do I think I ever will, but this probably sounds very similar to a lot of stuff we do. And I think this comic can, in some ways, kind of illustrate a pitfall we might fall into. This isn't actually XKCD. This is my friends at a company called Datascope. So it says, there's two data scientists talking to one another, and it says, we have this awesome data on insert mouth-watering description of data. We cleaned it up, and we're running a sophisticated analysis on it. We expect to see a story about fascinating patterns. Isn't that cool? And the guy says, booyah, it sounds like so much fun that you're doing. Why are you doing that? And he said, well, we're not sure yet. Imagine the possibilities. This has to be valuable. And then the one data scientist kind of smacks the other. So I think we do this. I think we sometimes become fascinated by these new shiny objects, these new shiny tools, these new techniques, but ultimately we lose sight of the problem. Why are we working on this? What's it for? What's the problem we're solving? The reality is much like design, data science is about answering questions and solving problems. That's ultimately what it is at its core. Would anyone disagree with that? It's shockingly no. So it sounds a lot like Mike's quote earlier. And while we might not technically have the title of designers, I would actually argue that we probably are designers. How many of you have a process that probably looks pretty similar to this? So there's empathize, define, ideate, prototype, and test. Does anyone kind of work with this approach? No one? All right, we got one person. But so it goes by a lot of names. You hear Agile, Scrum, maybe the Deming wheel. The concepts are all similar. This is the design process. And this is actually an image taken from Stanford's design school. Now, who remembers the Netflix prize? Does anyone remember that? A couple of you. OK, so I'll talk a little bit about that and maybe how the design process might have impacted that. So the Netflix prize was, I think it was around 2006. Netflix said, OK, we're going to give a team, you need to improve our recommendation algorithm by 10%. I think it was reducing the root mean squared error by 10%. And people spent 3 years trying to reach this goal. Ultimately, you saw quick gains in, I think there was an immediate reduction by about, there was an 8% reduction, I think, within the first 6 months of working on this project. And then for years, everyone was eking out trying to get the next decimal point to ultimately get to 10% for the $1 million. Many years later, a team finally reached the 10% gain. However, Netflix ultimately said, well, we can't use it. And instead, they realized that if they just created profiles with accounts, or if they created profiles within accounts, that improved their recommendations by the amount. So ultimately, they missed the boat. Everyone needed to step back from their solutions, the fact that we needed to improve the metric by 10%, and really think about the problem, to define it. The reality was that many of the users were sharing accounts, which was muddying up the data water, so to speak. So part of the oversight was that they didn't really start with the problem they were trying to solve. Instead, they started with the solution that they wanted instead of actually defining the problem. And I have a former coworker, Mike Stringer, who used to say, be concrete with your goals. So Netflix set their goal here. We want a 10% reduction. And it's good to be concrete with your goals. But state your problems in an ambiguous manner so that you can know, you leave some openness, some ambiguity to understand the problem space and to really define the problem space. And now to get into one final false dichotomy that I think I see a lot is data science versus user research. We're generally doing kind of quantitative research and they're generally doing qualitative research. But is it really that simple? I think by this point in the talk, all of you kind of have an idea where this is going. It's a trap, right? This isn't some quantitative research or qualitative research. The reality is that we should be doing both. It's extremely rare that we're so constrained that we can only choose one or the other. Last night I was Googling user research techniques, and this is something that came up. Now, if you look at the landscape of user research methods, over on the left, we see kind of the behavioral approaches, right? So and the more qualitative ones, ethnographic field studies, usability labs, so sitting down with users and actually watching them work, speaking to them having them think aloud while they're kind of going through your product and understanding what they're feeling and kind of what their issues might be. But look closely at that top right corner. They're quantitative methods. A/B testing is being considered a user research technique here, and we'll come back to that a little bit later, but it sounds already like we have a lot in common with them. Most users I've worked with have tended to live in the left half of this chart, the kind of the qualitative behavioral methods. All these techniques are great, but each of them suffer from their own common problem. They're narrow. So user research studies, they're a little bit narrow, but they get deep. User research is great at many things, particularly a deep understanding of our users, their environment, their behaviors. But the issue is that how many users can we actually study in this deep manner? 10? 20? It takes a lot of time. This won't give us an understanding of all our users, but it allows us to generalize, to potentially even create personas about our users. Similarly, data science suffers from their own problems. They're just the opposite. As we've learned from talks on Spark, Dask, and even Rob Story's fantastic data bike shed talk earlier, sample size generally isn't a problem for us. We can work with terabytes of data without too much difficulty. But causality is hard. Data is great at telling us many things: who, what, where, when. But the one thing it often can't tell us is why. Our data doesn't speak to us. We generally have to speak for it. And why is often the most important thing. We don't know why something's happening, why a behavior is occurring. And that's important. And if we align ourselves properly, I think with our colleagues in user research, I think we're positioned well to kind of create this nice feedback loop, allowing each of us to build off of each other. I'm terrible at illustration, so if I had had a scanner, I probably would have hand drawn this, but this was the best I can do in Google Draw. I mean, ultimately, we kind of have this data scientist who can kind of look at terabytes of data and end up saying, well, I'm seeing this weird thing in the data. I don't understand why it's happening. Maybe users are dropping off a page at a certain point, or they're struggling with a login box, or generally are just slowly moving away from your product. Their repeat purchase rate is going down over time. We don't really know why that's happening. Sure, we could potentially A/B test, but that inference is even also a little bit difficult at times. So we have to say to the user researcher, well, do you have any ideas? How can we explore this? And they can kind of go do that. They can provide context, that deep understanding, the knowledge of why something might be occurring by talking to users, by gaining an in-depth understanding with them. Similarly, a user researcher can say, well, I saw this weird behavior in a user research interview. But if you remember, they can only probably talk to 10, 20 people. It's going to take a lot of time for them to gather that information. So they come to us and they say, well, is there data to quantify how often this happens? Is this really a problem? And I think this is an important thing to consider when working with our colleagues in user research, because in reality, our skill sets aren't supplementary, they're complementary. Where data science falls short, user research excels. Stephanie Kim gave a great talk yesterday about using NLP techniques to discover and measure points of friction within your user base. And not only was it an extremely practical talk, but I think it did a great job of subtly communicating these points that, again, they're not supplements, they're complements. Now, if you remember from the user research landscape, there was a little piece on A/B testing. So I want to talk briefly about that. Does everyone here know what A/B testing is? Yeah? No? No? There's some no. I'm catching some no's. So A/B testing is kind of randomized control experiments. You have a population of users, you split them into random segments, and you give them two different treatments, where that treatments may be a different type of drug, or a drug and a placebo, or you show them a different colored button on each web page. But because you have this randomized control, you can understand, did that button change actually impact the user's behavior? Did it get them to convert more, purchase more, spend more money, whatever it may be? But the problem is, so it's a technique to kind of optimize a given metric. But the problem is that with A/B testing, you kind of hit this after a while you hit this dreaded local optima. So by kind of pairing ourselves with user researchers and even our coworkers in design and engineering, we can kind of get past this local optima, I think. And so I think A/B testing in some ways is akin to hill climbing. And in computer science, there's kind of the traveling salesman problem. There's the hill climbing problem of trying to optimize and reach a global maxima. And if we're driven by data alone, A/B testing, if we're just constantly trying to optimize a given metric, we're at risk of hitting local maxima because we don't have a great understanding of where we are on the overall landscape. So if you look at the image on the left side, it's our design. It's the current existence of our page. Say we're an e-commerce website. And if we A/B test, we can climb up the hill a little bit further and reach that local maxima, but eventually it becomes difficult to kind of eke out more gains. And how do we have any idea that we're actually at a local maxima? It's very tough for us to figure that out. So one solution is to inject a bunch of randomness into our algorithm. So we jump around randomly, and essentially we move around to new points on the map, and we see if a new point is higher than our current point. And then if it is, well, we start climbing further from there. Creatives, designers are our randomness. For our product to reach new heights, we'd have to take chances. We have to inject randomness into it. If we continue to optimize the same thing, we'll run out of hill to climb. We need to evaluate designs holistically, not just incremental changes. These new designs are akin to jumping around the landscape. They're our randomness. And as we learn more about the landscape and its topology, we kind of have a better chance of reaching that global maxima. And so I think teamwork makes the dream work. By creating multidisciplinary teams of data scientists, user researchers, and designers, we're able to better inform everyone throughout the process to create better experiences for our users. In reality, if we think back to that feedback loop, it probably ends up looking something like this now. We have the data scientist and the user researcher working together, creating personas, understanding, and context for the designers and the engineers. Designers love this because it enables them to see the world through personas, through their user's eyes. They're kind of like method actors, right? And this is something that Mike Bontiero, who I showed the design quote from earlier, this is something he advocates for, is that designers, they're able to kind of get into, okay, well, if I understand that the user is a woman aged 23 who's maybe purchasing something while on the go, it kind of helps them to formulate how a design might have to look, how simple interactions might have to be. And so by doing this, we kind of were able to help them out with their roles. Data points about their users, coupled with behaviors, feelings, deep understandings from user research and data scientists. It even opens up the potential for tailored experiences, right? So if you have these personas, why do we take this one-size-fits-all approach? We could kind of tailor things to different types of users and then even feed data back in to show different types of treatments depending on which type of user we think that's going to work for. And so I have a former coworker who likes to refer to this as each of us having our own superpowers. Do any of you actually remember this cartoon? Captain Planet. Captain Planet, and that's Captain Planet and his Planeteers. And each of the Planeteers had a special natural resource power: earth, wind, fire, water. I'm forgetting other ones. But so I think we're in kind of a similar boat. By combining our skills with user researchers, with designers, we're able to kind of become Captain Planet and the Planeteers. This is what we should be striving for better outcomes for everyone by working collaboratively together. So it's important to remember that we're here to make experiences, not metrics. Even though we're about answering questions and solving problems, the ultimate end to what our work is an experience to a user, not the maximization of a metric. And I think Lorena talked a little bit about this earlier this morning in her education talk, that we're optimizing for experiences, not metrics like grades and test scores. And that learning is a unique experience, and we need to tailor approaches to our audience to use the available channels to communicate the concepts to students. So data is a powerful thing. It's extremely powerful, but we can't let it be the only thing we consider when making decisions. If we do, we're destined to lose sight of the big picture, why we're doing these things, the problems we're trying to solve, and the goals we're setting out to achieve. And I'm kind of going to close out here with a quote from Nate Silver. If any of you haven't read his book, The Signal and the Noise, I think it's an excellent read, and that everyone, whether they work with data or not, should kind of give it a once through. And in the book, Nate said this about making a good forecast. I think it applies not only to forecasts, but all the decisions we make. That the key to making a good forecast is not in limiting yourself to quantitative information. Rather, it's having a good process for weighing all the information appropriately. This is about the end of my talk. If you've enjoyed it and you're interested in more in-depth pieces on the topic, these are some great reads. Many of them were kind of resources for forming this talk, and they do a far better job of kind of explaining and covering this type of stuff than I can. I'll post these online to GitHub, and I'll tweet them out later in case anyone wants to kind of click through these links as well. So thank you very much. If anyone has questions or comments, I'd love to hear your thoughts on all of this.